Hello friends, today's question. A block of mass 10 kg is put gently on a belt conveyor system or infinite length at t is equal to 0, which is moving with constant speed 20 meter per second towards right at all time. A constant force of magnitude 15 Newton is applied on the block continuously during its motion. So we have these three questions based on this. In the first part, we have find out what will be the nature of the friction force acting on the block. In the second case, we are going to find out the work done by the kinetic friction, and in the third part, we are going to find out what will be the magnitude of acceleration of block of the mass 10 kg at t is equal to 6 seconds. So these are the three questions based on it. So let's consider question number 1. And it is asked the nature of friction force acting on the block of mass 10 kg during its motion. So it means as soon as this, let us suppose this is the conveyor belt and it is moving in this direction with a constant velocity of 20 meter per second. Now as soon as the block of mass 10 kg is kept on it, this is 10 kg, there will be, now this conveyor belt will try to move this 10 kg block in the right direction, or we can say in which the direction it is already moving. So this will be the direction in which the box will be traveling, okay, and this will be because of the force of friction between the box and the conveyor belt. So under this condition, there will be a relative motion between the box and the conveyor belt, so the friction will be of kinetic in nature. Okay. After some time, what's going to happen? This velocity of the box will become slow and steadily almost equal to the velocity of the conveyor belt. So under this condition, the relative motion between the box and the conveyor belt will be 0. Now in that case, the friction will be static in nature. Okay, so we can say that the friction is going to start with kinetic and then it going to end with static. So option number C will be the correct one, sometimes kinetic and sometimes static. Okay. So we can explain it this way: as soon as the block is placed on the conveyor belt, the belt will try to move block towards right direction. As such, therefore, because of, let me write it, because of friction force Fr between block and the belt Okay. This will result in the relative motion between belt and block. Okay. Therefore, the nature of friction will be kinetic. But after some time, the speed of belt or box or block will be equal to speed of belt. Okay. So this will result in, therefore, there will be no relative motion between block, or we can say box also, and the belt. There will be no relative motion. So it means now, therefore, the nature of friction will be static. So we can draw a conclusion, which means friction will be kinetic and static. Okay, so therefore the option number C is the correct one. So you can say option C is the correct one. The second part, we are going to find out what will be the work done by the kinetic friction on the block of mass 10 kg. The second part. Now this is the conveyor belt, and on this conveyor belt we have the box of 10 kg, and external force is being applied on it. Let us call this F, which is 15 Newton, and there will be a force of friction Fr acting on it. Okay. So we can say that let us find out our Fr. Fr is equal to mu kinetic into normal, okay, and normal is equal to mg, so this will be mu into mg. Mu is given as 0.25, mass is given as 10, and g is also 10, so we get our Fr is equal to 25 Newton. So the box is under the influence of two forces, F as well as Fr, okay, and we say let it is having an acceleration A. You can say box is under the influence of two forces F is equal to 15 Newton and Fr, which we found as 25 Newton. So we can see net force, as they are in same direction, will be F plus Fr, which is equal to 15 plus 25, and net force, let us denote as F net, is equal to 40 Newton. If A is the acceleration of the block, if the acceleration of the box is A, so A will be equal to F net divided by mass. F net is 40 divided by 10, so we get our acceleration as A is equal to 4 meter per second square. So this is the acceleration of the block, and we are supposed to find out what will be the work done. Okay, now for work done will be equal to force multiplied by distance. Let me write it here. Work done is equal to force multiplied by distance. This is the work done. So we already know value of the force. Next we are going to find out what will be our you can say work done, distance, sorry. So we already know that initial velocity of the block is 0, okay, and final velocity is it's 20 meter per second. So we can find out the distance, okay, you can say using equation of kinematics, which means v square minus u square is equal to 2as. U is 0 and v is our 10 meter per 20 meter, 20 meter per second. So we can find out our distance s. So s will be equal to 20 into 20 divided by 2, acceleration is 4. So this comes by 10 and this comes by 5. So distance will be over 50 meters, sorry. And we are supposed to work done by the kinetic friction. Okay. So we can say work done by kinetic friction will be equal to W, which is equal to force of friction, which is kinetic, multiplied distance s, and Fr we already know is 25. So work done W, Fr is 25, this multiplied by 50, this comes as 1250 joules. Now the sign will be positive because the direction of the force which acting at the distance traveling is same. Okay, so sign is positive because of direction of friction Fr is same with the displacement along the belt. So this is our second part. So we get this as answer will be A, that is 1250 joule. Okay, so here we can write option A is the correct one. And the last is magnitude of acceleration of the block of the mass 10 kg at time equal to 6 seconds. So first of all, we are going to find out what will be the, at what time the velocity of the box becomes equal to the velocity of the conveyor belt. Okay, so this is the third part. Okay. So let at time t is equal to t naught, speed of box becomes equal to speed of the belt. Oh, belt means conveyor belt. So there means that speed of box at t is equal to t naught will be equal to, let us suppose this is equal to v box vb, and this will be equal to 20 meter per second. And we already know that their initial velocity is 0, so using v is equal to u plus at, and u is 0 and t is t naught, so we can say v is our 20 and u is 0, acceleration is 5, a was, sorry, not 5 but 4 meter per second square, and t is t naught. So from here we can say that our t naught will be equal to 5 seconds. So at t is equal to this 5 second, the velocity becomes of the box as well as belt becomes same. Okay. You can say that at time t is equal to 5 seconds, speed of box becomes equal to speed of the belt, and belt is moving with a constant speed, and belt is moving with constant speed. So as their speed becomes equal, there will be no relative motion. It means no relative motion between box and the belt. Okay. So this results means acceleration of the box will be 0 for t naught greater than 5 seconds. Okay, for t naught greater than 5 seconds. Here we can say it is asked for time t seconds. Therefore, acceleration of box at t is equal to 6 seconds will be 0. So we have the option D, that is none of the above. Okay. So we can say option D is the correct one. This completes the question. Thank you.